Hi, my name is Adriana Hazwani. I'm from Group 2. Our title project is Application of Numerical Mathematics in Civil Engineering area. Next slide, I will introduce our group member. First, Adilina Hazwani binti Shambuddin. Second, Nur Alia Husna binti Muhammad Zain. Third, Muhammad Aiman Muhafiz bin Idris. Fourth, Nur Aisyah Najiha binti Muhammad Zamri. And the last one, Adriana Hazwani binti Shambuddin.
Assalamualaikum, my name is Nur Aisyah Najiha binti Muhammad Zamri and my matrix number is Bfc25203. So I will present about introduction parts, which is about background of the studies. Trusses are structural frameworks used in buildings, towers and bridges. They carry loads efficiently using axial forces at the tension or compression. Thrust analysis determines internal forces under external loads, such as forces due to weight, wind or vehicles. Each joint and member respond by redistributing the load internally. Based on static equilibrium principle, total Fx equal to 0 for horizontal forces, total Fy equal to 0 for vertical forces, and last one, total moment equal to 0. By applying this equilibrium equation to each joint of the truss, a system of simultaneous linear equation is formed, where each unknown corresponds to an internal forces in a member or a reaction forces at a support. So for the large system require numerical methods like Gauss elimination method. Next, we continue to the problem statement part. We analyze a 2D truss with 3 members, which is AB, BC and AC. We use 10 kN horizontal load applied at joint B. So for the support at joint A, we use pin support, and joint C, we use roller support. We assume that members are connected using frictionless pin, and then neglect the self-wear of the members. So we use static equilibrium to set up a system of equation and solve using Gauss elimination method to find the axial forces in members AB, BC and AC. There are 3 objectives of this study. The first, to formulate the static equilibrium equation by using the principle of static. We use the principle of static equilibrium to derive a system of linear equation that describe the internal axial forces in member AB, BC and AC, and the support reaction at A and C. Second, to determine the internal forces in truss members. We compute the axial forces in members AB, BC and AC, identifying whether each member is in tension or compression. And the third, to apply the Gauss elimination method to solve the system of the linear equation. We solve the system of linear equation using the Gauss elimination method, a standard numerical technique for solving system of equations.
Hi, my name is Adilina Hazwani. My matric number is CF230222. I will continue our presentation. Literature review. Numerical methods in civil engineering. Numerical methods provide systematic technique for solving engineering problems. Common application, structure analysis, fluid mechanics and soil mechanics. Gauss elimination is a key method used to solve system of linear equation. Truss structure analysis. A truss is a structure made of straight member connected at joints. Assumption, all joints are pin connected, load act only at joint. Goal, determine internal axial force in member. Gauss elimination. Convert a system of linear equation into a upper triangular matrix. Solve using back substitution. Equation for engineering problem involving multiply equation. Commonly used in structure computation, finite element modeling.
Hi, my name is Muhammad Aiman Muhafiz bin Idris. My matrix number is DF230074. We will continue our presentation about part of methodology. So we will see about the thrust analysis for this project. We will define thrust geometry and loading at joints A is a pin and the joints B is a roller support and the joint C is we apply a 10 kN horizontal external force. at joint C. So we will assume all the joints are connected by the frictionless pin and each member is loaded by axial force. Then we will sketch a free body diagram FBD for visualization of all force on the system. And then we will apply the statistic equilibrium force is 0, net of vertical force is 0, and net of moment around any point is 0. So next, we will see the Gauss elimination method. So the Gauss elimination method is simple direct method for linear system solution in this numerical method. So the equilibrium equation are arranged in a augmented matrix from that, as we can see at the slide. So next we will Forward elimination is used to eliminate variable from the rows following. So next we will back substitution is applied to solve each unknown in turn on substitute it back into the earlier equation. Lastly, the force are calculated to satisfy the requirement into sum of fx equal to 0 and sum of fy equal to 0. So ensuring mathematical precision and structural safety in design practice. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nora Lausna binti Muhammad Zain and my metric numbers is Bfc25203. So for this project, I am the person who in charge for the calculations of this problem. There are a few steps I use to solve this case. So for the first step, I draw the free body diagram of the truss structure, including the external load, and the dimension. As you can see, at the free body diagram, at A point, there is a pin support, while at B point is the roller support, which is at A point, it's gonna have two reaction exert on that point, which is RAX and RAY, while at B point, there will be only one reaction, which is RBY. So the next step is we have to find the value of the support reaction first before we proceed the calculation. To find the support reaction, we have to use the knowledge that we learned in static dynamic course. So we have to use the three basic equilibrium equation, which is m equal to 0, fy equal to 0, and fx equal to 0. So the result is for the RBY, it's 10 kilonewton outward, and for the RAY and RAX is 0, which means there is no reaction at both points. After that, we proceed to the next step, which is we use method of joint to form a equation of system. So why we need the system of equation is actually because of the system of equation, we have to convert it into the matrix form so that we can solve it using the Gauss elimination. So at first we have to find at joint A, which is the equation that we get is FAB minus 0.8 FAC equal to 0. That will be the first equation. Then we proceed to point C, which is the equation that we formed from it as negative 10 minus FCB minus 0.6 FCA equal to 0. So for now, we have two equations that we can use. But for this case, we need to have three equations because there is three members of this structure, truss structure. So from equation 1, we can derive as FAC is equal to FAB divide 0.8. Then we substitute it into the equation 2. It will be negative FCB minus 0.75 FAB equal to 10. That will be the third equation. As we get all the three equations, we have to assemble it and then rearrange it and convert it into the matrix form. So when we arrange it into the matrix form, we can proceed to Gauss elimination method to solve this find the internal force for this truss structure. So for this method, we have to make sure all the element under the main diagonal is 0. So when it's not 0, we have to eliminate it. As you can see, here is negative 0.75 and negative 1 is not 0. So that we have to eliminate the C row. The way that can we use to eliminate that negative 0.75 is that we use the formula and then we insert the formula into the calculator. As we need to eliminate negative 0.75, we have to use it into the formula of negative bracket. What inside the bracket is negative 0.75, which is the element that we need to eliminate. So we divide it with the element of the main diagonal with in the same column, which is 1. So the equation will be negative in bracket negative 0.75 per 1 A plus C. So after we calculate it by using calculator, we still get another one element which is not 0, which is in this case there is negative 1 which is not 0 below the main diagonal. So we have to eliminate it using the same formula. After we get all the element below main diagonal is 0, we can proceed the calculation to find the FAB, FCB and FAC. So for this case, we get FAC is equal to 0, FCB is equal to negative 10 and FAB is 0. Then we have to identify the type of force of this internal force, which is FAC is equal to 0. That means the member is 0 force member. And FCB is equal to negative 10, which is, it means the internal force is in compression condition. And next is FAB equal to 0. That means it's a 0 force member. So I think that's all for me. Thank you.
The last slide is conclusion. This project successfully demonstrates how to apply Gauss elimination in solving a system of equations arising from truss analysis. The results show the axial force in each member and their nature, tension or compression. Numerical methods like Gauss elimination have proven to be reliable and efficient for structural computation in engineering. That's all from Group 2. Thank you.